Second view would be like this, lying on HP. So its top view would appear like this, front view would appear like this, both will be similar. So here it is given, after lying it on this, on HP, it is cut by some cutting plane like this. We have to slice this like this. It removes this upper portion. So how to draw this? So for that, let me start the drawing this problem. Draw its top view, divide the circle into equal number of parts, draw its front view, triangle having its given height, that is 50 mm axis and 40 mm diameter. Redraw this front view like this. Why we redraw? Because here it is given that it is lying on its one of its generator like this. So here we assume that it is lying on O-E- generator. Here this O-E- generator is to be transferred over here, and it is redrawn like this. After redrawing this front view, this is the front view which is just redrawn such that its O-E- line becomes on XY line. Take generators from its front view, these vertical lines from A dash, B dash, C dash, D dash and all these points which we exercised in previous section how to draw projections of solids. Draw vertical line from all these points, horizontal lines from the top view, mark these points A dash, B dash, C dash, D dash, A1, B1, C1, D1, E1, F1, G1 and H1. Join them with the smooth curve, and from point O draw vertical line, O dash vertical line, this is point O1. Join these points with a straight line, this is its top view. So this is just a projections of given solid. Now how to draw this cutting plane? Here it is given that the cutting plane which is parallel to VP and it is cut by a cutting horizontal section plane through its base center. So base center is over here. This is the base center. Draw a horizontal line, passes through this base center like this. So this cone is cut like this. This uppermost portion is to be removed. And draw vertical lines from all these points which cuts the appropriate generator at certain point. Join these points with a smooth curve, and this is true shape of the section or sectional top view. These are both the views, sectional top view as well as true shape, because this cutting plane is parallel to XY line. So here no need to redraw its true shape because this is a true shape. You can see here this is a horizontal section plane. This is a front view of given solid. So all the conditions which are given over here are satisfied, that dimensions are given, diameter is 40 mm, height is satisfied, that is 50 mm. It is cut by a cutting plane which is parallel to vertical plane. So this cutting plane is parallel to vertical plane, and this is its sectional top view as well as true shape of this given solid. So you can lighten another portion. In the previous case this is here, you can remove this because it's a removed portion. So this is the remaining portion, this is true shape, and this uppermost portion also should be lightened or removed. So only this much remains with us, this solid remains with us. This is true shape of the section. You can see here this is removed portion. So this is final answer. Front view is cone, front view is triangle, top view is circle. This is a removed portion, this uppermost portion is removed, and this is true shape of this given solid. Sectional top view, true shape and horizontal plane. Another problem of hexagonal prism. You can see here hexagonal prism of 30 mm sides and base, 30 mm base and 50 mm axis is lying on HP on its rectangular face with axis parallel to vertical plane. So similarly here same exercise to be adopted. Hexagonal prism is given with 30 mm sides and 55 mm axis. It is lying on horizontal plane on its rectangular face. You can see here something different is given over here. It is not lying on its hexagonal face, it is lying on its rectangular face. So first of all, draw a hexagonal prism of given side length, that is 30 mm base and 55 mm height. Here it is given that it is resting on its rectangular face. You can see here. See, this is a hexagonal prism, right? This is hexagonal prism. In the previous problem, we assumed that this hexagonal prism is lying on its hexagonal base. So we drawn its top view like this, front view rectangle and drawn. But here something different is given. Here it is given that it is lying on its rectangular face. So this is a rectangular face. This one, 6 rectangular faces are there. 1, 2, 3, 4, 5, 6. It is lying on its rectangular face like this. So this is a given problem. It is lying on rectangular face, so its front view would appear like this. If it is lying like this, then top view would also appear as a rectangle. So front view is rectangle, top view is rectangle. So first we assume that it is lying on HP like this. So its top view would be hexagon like this, and top view would be would be rectangle like this. After drawing this top view, we will tilt this like this, right? So this is first view, this is second view. Tilt this at certain angle and make such that it becomes parallel to XY line. After lying it over here, put it over here, draw the third view or draw its front view like this, then take projections and find out its true shape, its top view. It would be like this, right? So here, after drawing this hexagon like this, draw its true shape, draw its top view and front view, and tilt this front view like this. Make it horizontal. Take projections from top view, horizontal lines from front view, and draw its top view as well, like this. So we have drawn front view and top view. Now it is given that it is cut by some cutting plane. Cut by a section plane normal to horizontal plane and 30° inclined to vertical plane. So it is cut by a cutting plane which makes an angle of 30° with a vertical plane. So from XY line, or the line which makes an angle of 30° with XY line, draw a section line. This is a cutting plane line. This line makes an angle of 30° with XY line and it bisects the axis. So find out midpoint of this and bisect it. Now this is auxiliary vertical plane 30° to VP. Cutting plane which makes an angle of 30° with vertical plane. Mark the points. Here 2 points would be there, 1, 2, 3, 4, 5, 6, 7 and 8. So 2 points would be there at each corner. 2 points over here, 2 points over here, 2 over here and 2 over here. Name these points. From these points draw vertical lines like this, 1, 2, 3, and locate appropriate sections in front view and top view and mark these points 1, 2, 3, 4, 5. Join them with a straight line and draw section lines. This is sectional front view, this is sectional top view. And to draw its true shape again, do similar exercise. Draw lines perpendicular to x1 y1 line which we did earlier. Find out true shape like this and draw section lines to this true shape. Name this point. This is a sectional front view, this is top view, and this is true shape of given section. So here you can draw this true shape anywhere in this diagram. You can project this line to the bottom side or to the upper side also. Wherever space is available, it could be drawn. So this is the problem which is given over here. Now a very important problem or some typical problem is given over here. You can see here, it's a combination of solid. A solid composed of a half cone and half hexagonal pyramid, which is shown in figure. In figure it is given half cylinder, half cone and half hexagonal pyramid. Both are given over here. It is composed of two half solids. It is cut by a section plane 45° inclined to HP. So this is first. Draw its top view, its front view which would appear as a triangle. Draw a section plane. In this section plane, this cutting plane makes an angle of 45° with XY line. So draw a line at an angle of 45° with XY line which passes through the midpoint of this axis. Name these points 1 days, 2 days, 3 days, 4 days, 5 days, 6 days and 7 days. Name these points and translate these points to its top view. There 1, 2, 3, 4, 5, 6 and 7. And here similar analogy is to be employed because this is a true length. So from this 2 days, 6 days to a horizontal line which cuts these true lengths at some point over here. From this point draw a vertical line which cuts this OA or this generator at this point. Draw an arc on this side, draw an arc on this side as well. Mark these 2 points and join all these points on this side. Join all these points with a smooth curve, and on this side join all these points with a straight line. So this is our cut section. After cutting this solid at certain angle, this would appear in the top view. And in the top view you can draw section lines like this. Here both the section lines are drawn at different angle. This angle makes this is 45° on this side this solid makes an angle of 45 degree with this side, because this is a combination of solid. Both the solids are different, so we have to draw different section lines like this. Section lines on both the sides, sectional top view. Now to draw true shape, similar analogy to be employed which we did earlier. Draw true shape, draw section lines, and this is the true shape. Name them these points 1, 2, 3, 4, 5, 6 and 7. Again here draw its sectional lines such that these section lines make an angle of 45 degree with x1 y1 line, not xy line. This is x1 y1 line, and this angle between this line and this line is 45 degree. So this is the solution of given problem. This is true shape of given solid. These are the points which are to be covered. So you can use internet to solve such kind of problems. engineeringgraphics.wordpress.com, engineeringdrawing.org, slideshare.net, studyvilla.com. As well as I would be happy if you contact me to my email address ssonigra@gmail.com for any kind of discussion related to this problem. So in short, today we have discussed 4 types of solid, that is prism, pyramid, cylinder and cone, which are widely used in industries. In industry, some basic shapes are there. In industry, variety of shapes are used, but as far as the education is concerned, we have covered just 4 regular shapes, that is prism, pyramid, cylinder and cone. Now if you clear the basic concepts or basic contents, if you digest the basic concepts, then you can solve any kind of problem which are to be given to you. Suppose it is given that the solid is cut at certain angle makes an angle of horizontal plane, or it cuts at an angle of certain angle with vertical plane, then appropriately you can draw its various top view and front view or true shape of the section. Suppose one case we take over here, that is of cylinder. It is drawn over here. You can see here the cylindrical shape is given. Here the diameter of cylinder is given, so you first draw a circle of given diameter, say 50 mm or 40 mm like this. Draw a circle of given diameter like this. From this circle divide into equal number of parts, say 1, 2, 3, 4, 5, 6, 7, 8. Draw vertical lines, draw front view like this, which is a rectangle over here, right? Then after, this is the remaining solid. Once we cut at certain angle, to draw its true shape, again draw a line which is perpendicular to this line or perpendicular to this reference line. Mark here points 1, 2, 3, 4, 5, 6 or A, B, C, D, E, F. But here you take care about this. These section lines should be drawn like this, such that this section line makes an angle of 45 degree with this reference line. So this is true shape of the section, this is front view and this is sectional top view. Here you should not forget about the inserting the dimension like this, 540 or 550. Dimension should be inserted at appropriate place. This height is 45 mm. The height of this cutting plane is 45 mm, which should be inserted like this. 45 mm is the height, like this. Here aligned system of dimensioning is used. Generally we have adopted this system to insert the dimensions, and this is the true shape of given solid. So these are the basics related to the sections of various solid. So in short, the very basic is, first imagine the given position. It is resting on HP or resting on VP. If it is given that it is resting on HP, then first draw its top view, right? So in top view it would be a regular polygon or circle. In case of cone and cylinder it would be circle. In case of polygon it would be appropriate polygon. So if it's a pentagon or hexagon, the top view would be appropriate. Now after drawing this first view, imagine what angle is given. Angle with HP is given and angle with VP is given. If angle with HP is given, tilt its front view at a given angle, and after redrawing its front view at a given angle, take projection lines from front view, locate it to the top view, draw horizontal line from top view and find out its top view. So this is regarding the sections of solids. I am very much thankful to all of you for sharing with me this discussion, and I would be happy if you call me regarding this technical discussion. Thanks to all of you.